Okay, in this video, I will answer a couple of example questions using normal distribution, either norm.dis or norm.inv in Excel. I won't actually be doing it in Excel. I think the graphical understanding is more important here. And also in the exam, I won't be asking you to do things in Excel. I might ask you, what input would you put in Excel? What input would you use in Excel to answer a given question? But ultimately, I will not be asking you to do the things in Excel for the exam directly. You might have to use it for the interview exam or other things like that, but not for the actual normal midterm. Okay. Okay, so the first question we have here is the NPV for a project is normally distributed with a mean of 30,000 and a standard deviation of 20,000. We want to calculate the probability that the NPV is going to be below zero. And this kind of makes sense here, right? If the we want to do the project if the NPV is bigger than zero. So asking ourselves, well, what's the probability that our NPV in the real world will actually end up being smaller than zero? If we want to do that, what we want to do is we want to put this point here and we want to calculate all of the area under the curve to the left of this point. Okay, well, if you remember the previous video correctly, this is exactly what the norm.dist function does in Excel. Okay, and I would like to evaluate it at a value of 0. So I'm going to use the function norm.dist, evaluated at 0. The mean of our normal distribution is 30,000. The standard deviation of our normal distribution is 20,000, and I want a cumulative distribution function. So I put 1 here for cumulative distribution function. Okay, next question. Suppose that instead we want to calculate the probability that the NPV is above 10,000. We have exactly the same information, but now we just want to calculate the probability that the NPV is about 10,000. So what we want is, suppose we have 10,000 here. Notice, by the way, I put it to the left of the peak here because the peak is the mean. So the peak is 30,000. So 10,000 is smaller than the mean. So it goes to the left of the 30,000. This is actually pretty useful to think about this when you work with normal distribution, because we know now that the answer should be bigger than 50%, right? The mean has 50% of observation to its right. So if we have a value here, 10,000, and we want to know the value to the right of this, well, we know it should be bigger than 50%. Okay, so this is the area we want to find. We have a problem here. Excel cannot give us this area. We cannot ask Excel to directly calculate this area. Excel can only calculate area to the left of a value, right? But the good news is we can take this whole area, the whole area underneath the curve, that's 100%, and we can minus the area to the left of the 10,000 of this value here, and that's going to give us what is left in blue here, and that's all we have to do in Excel. So I want to do 100%, which is 1, minus norm.dis, and we want to evaluate this function at 10,000. The mean of our distribution is 30,000. The standard deviation is 20, and we want a cumulative, the cumulative normal distribution. So we put 1 as our last instrument, or yeah, not instrument, input. Okay. Okay, next question. We have the same project with the same mean and the same standard deviation. And now we want to calculate the probability that the NPV will fall between 25,000 and 50,000. So I take my normal distribution. And again, by the way, I always do this. I always draw these graphs when I work with normal distribution. If you don't do this, this is where you make mistakes. It's really not that that hard if you take the time to draw it out. If you forget, if you decide not to draw it out, you will have concern, you will make mistakes, and it's usually silly mistake just because you didn't look at it visually first. Okay, so I draw 50,000 here. We know that the mean is 30,000, so I know the mean is here, and I know that 50,000 will be to the right of the mean. I can use the norm.dis function in Excel to calculate all of the area left of this point, right, or of this dotted line. Okay, and I have 25,000 here, and I can use the norm.dis function in Excel with 25,000 as an input to calculate all of this area here. So what do I need to do? Well, I want the orange area minus the blue area, right? If we go back, I want all of this area minus this area here. Well, we can easily do that in Excel. I used the norm.dis function, evaluated at 50,000. That's going to give us the whole orange area. The mean is obviously 30,000 and the standard deviation 20,000. And then I minus the area below 25,000. So I use norm.dis, evaluated at 25,000. And that gives me 44.01%. Okay, last question. Suppose now we have the same project, right, with the same distribution, same mean and standard deviation, but now we don't want to calculate the probability that we fall below or above a value. We want to calculate, right, what value, what MPV, right, will have 75% of the MPVs below it, right? So if I want to find a point here, I want to find a point here where this orange area is 75%. Okay, so how do I do that? Well, that is the other function I talked about. That's the norm.inv function, right? So I'm going to use the norm.inv function. I'm going to evaluate it at 75%. Okay, the mean is 30,000. The standard deviation is 20,000. You don't use, I don't have an example of this here, but we never really use like 1 minus norm.inv. There's never really any case to do that. For example, if the question said find the value for which there's going to be 25% of the observation above it, right? Well, you would just use 75 again. You would just draw it. You would say, I want 25% here, so there needs to be 75% of observation here. And we just use the same input in that case, and the answer should be exactly the same. Okay, and that should cover everything you need to know for a normal distribution and all the examples that I had.